I'm going to discuss about RHEL types. So the concept of RHEL. So RHEL is redundant array of independent disks. In some documentations, it written as a redundant array of inexpensive disks. So basically, what the concept of RHEL is that maybe you have multiple hard disks in your system, but in some cases those hard disks will consider as one in your system. So only thing about RHEL is, and the only thing you will get from RHEL is one, it increase the working of an input output operation. It means it increase uh, uh, your entire working entire computer speed about the input and output operations, like copying data or uh, backing or saving data. Another thing is about redundancy. So with those red labels you can create a backup. So basically two types is there, either it increasing the operations of the computer or creating a backup. So a type of red labels are there, and redundant array of independent is basically used in the infrastructure environments, but maybe in the big infrastructure environments. But sometimes we even in our own life, when want some database to be saved, we create a backup, we save in external hard disk or somewhere. So basically we are doing in our own life by backupping it, by purchasing extra hard disk. So basically we use those in infrastructure environment, but in the uh, in the in the personal environment we use those extra hard disks for backupping. And in the infrastructure environment, definitely they increase the operation, the read write operation. Now the first type of RHEL is RHEL 0, and now you can see that RHEL 0, the database saved in a stripe form. Stripe, you can see block 1, block 2, block 3, block 4 is there, but block 5, the you can see one thing, that it will not allow you to uh, it will not allow you to basically create a backup. It will not give you a redundancy. It will increase the input and output operation, but it will not uh, give you a backup. It will not give you a redundancy. So it will increase the read write operation, input output operation, but because it don't have a backup, it won't have a copy, that's the reason it will give you a one benefit, not two. So with this hard disk you can won't get the redundancy, but speed up will increase. So uh, some ways it's the last thing. Now red one is a mirror on both drives. It means you are using two hard disks, but one hard disk will be a mirror of another hard disk. It will increase the possibility of a redundancy more than that what we used to get in RHEL 0, because RHEL 0 is completely zero in redundancies offering, but in RHEL 1 you will completely have redundancy, especially because both are the hard disk 1 and hard disk 2 a complete copy of each other. It will be a complete mirror. It will be complete uh, sequential copy of each other. Stripe will be there, but Stripe complete copy of each other. So it's a mirror, and it will be available in the mirror form. Rest is it will be available in a stripe form, but a complete copy. Now red 5 is parity across disk. You can see that the 4 hertz is available, and basically we require at least 4 to perform this red 5. Now you can see the block 1A and block 2 and block 3A. What red 5 offers, it not only increase the operation, a read and write operation, but it will also good enough to but it will also good in the backup way. It will provide you a parity. So not only block A1A, block 1B, block 1C will be in the stripe form to increase the performance of the system, but also these block 1A, block 1B, 1C will be backup and will be available in the parity form. You can see 1A, 1B, 1C, for example, will be on the parity form. 2A, 2B, 2C will be on parity form. 3A, 3B, 3C will be in the parity form. 4A, 4B, 4C will be in the parity form. So it will be in sequencing for parity form, and 4 out of 1 stripe will be dedicated for the parity, and 3 will be for the data savings. So not only it will increase the performance, but it will also give you a backup. Now RAID 6 will be same. Again, it will have 2 stripe. If it covers 2 stripe for backup. For example, block A, block B1 will be available as backup, like AQ and AB will be a backup in the disk tree. Similarly, in A2, D1 will be a backup and will be available, for example, in disk 4, AQ and a DQ. Similarly, CQ and DQ will be a backup and may be available in the it will be a backup maybe available of this 3 stripe, and 2 stripe will be of database. So basically it will provide you a 50% of storage. Size will be of 2 hard disks, no matter we are using 4, but it will be in the 2 hard disks. So at least -2 if we are using more and more hard disks in the future, but at least 2 hard disks will be covered up with this, creating dual parity. Now RAID 10 will be a combination of RAID 0 and RAID 1. RAID 1 basically will be a mirror of and will be a mirror in 2 hard disks, and RAID 0 will increase the performance of increase the operations in the working. Now RAID 6 and RAID 10 is almost same, but the only thing is the saving of a database. Otherwise RAID 6 and RAID 10 is almost same. You can see the previous almost 2 hard disks is covering up for the database. Here also 2 hard disks is covering up with the same database. RAID 1 will be the mirror. 4 hard disks, for example, you're using 4 hard disks, the 2 will be of RAID 1 will be for the read for at least for the backup, and RAID 0 will be the mirror form and will increase the read and write operation. Will increase the read and write operation. The types are RAID and a couple of RAID areas we're supporting in Linux. Now Linux is a great operating system. Red Hat is a great operating system to perform and to implement RHEL, and we will learn about it in the upcoming videos. Hope you learned something from them. Thanks for watching.